In this video, we're going to approximate a binomial probability using the normal distribution. So take a moment to pause and read through the problem setup and the questions that are being asked. So the first thing I want to do is actually come here to some information about the normal approximation to the binomial probability distribution. And this is in your text, your etext on section 7.4. So let's find these values, n and p, where n is the number of trials and p is the probability of success. And with it, we'll first calculate to see that we can use this normal approximation with this formula. And then if we can, and I suspect we can, we're going to find the mean and the standard deviation that we need to continue and finish this problem. Okay, so let's go back up and grab the number of trials, which is right here, n, and the probability of success, which is right here, but written as a percent, 0.35 is what we'll use. Okay, so let me rewrite that here. All right, so I'm just going to turn to my calculator to first see if I can use this normal approximation. And what I'm doing is I'm trying to see if this expression, when I substitute n and p, is going to be greater than or equal to 10. Okay, so when I've typed that in, sure enough, it is greater than 10. So that means I can proceed. And in a previous video, I had mentioned something about how the standard deviation is very similar to that first expression you just had to calculate. So I'm going to go ahead and find that value first by taking the square root of this previous answer. And that's going to be the standard deviation that we use in a minute. And then I also want to find the mean, which is defined as n times p. And I'm going to record these values on my screen. One other thing I want to take note of right here is let's take several of these decimal places. I think I'm going to go to 4 decimal places for the standard deviation just to be safe. Okay, so next we're asked for a particular probability. And here it says the probability that at least 72 students would prefer a boy. Okay, with that other given information that we've already used. So that 72 students would be an exact value, right? If we were doing this as a binomial distribution, this is the way we would write our probability statement. Greater than or equal to 72. But because we are approximating it with a normal model, we're actually going to back up 0.5 units. So we will do 71.5 right here instead. And I'm referring to this table that's in section 7.4, and I only cut and paste the information that we need for this particular problem that refers to an at least statement or a greater than or equal to statement. So treat this A as the 72 and think of it like this. You want to be able to capture the 72 in your area. And so to do so, that means you need to back up 0.5 units. You don't want to go a full unit less because then you're now at 71, right? So just a half a unit, either adding or subtracting, is what you do and see here in that particular table. Okay, so now we've got this value. I'm going to return back to my calculator and use the normal cumulative probability distribution. So I will find that underneath the distribution menu, the normal CDF. And I put in this information earlier. So our lower bound is now 71.5, because remember we wanted to capture the 72. So that means this number right here is the 71.5. And then it goes off into infinity, technically, but our calculator can only go to 1e99. That's the largest number that it can compute with. So that's what I've typed here. And if you recall, that E symbol is right here in blue. And the mean and the standard deviation we found earlier, let me scroll back up. That's these two values. I put those in there. And I will just paste this to my home screen. And now I have the probability that at least 72, what was it again? 72 students would prefer a boy. And that's this value right here, 0.0051 whenever we round to 4 decimal places. And again, that does contradict what the poll says because this value is less than 0.05. In other words, it's a very unusual result, that 0.05 kind of being the mark for unusual.